Find the Laplace transform of 3 cos t plus 5 sin 3t. Here we need to apply the two formulae. Laplace transform of sin of at, whose value is equal to a by s square plus a square. So, in the similar pattern, in the similar manner, the Laplace transform of cos at is s by s square plus a square. So that this problem can be solved in easy manner. So, let us solve it now. Laplace transform of 3 cos t plus 5 times sin 3t. Applying the linearity property, so this can be written the Laplace 3 times the Laplace transform of cos t plus 5 times the Laplace transform of sin 3t. Laplace transform of sin at formula equals to a by s square plus a square. Laplace transform of cos at is s by s square plus a square. Okay. Now this we can write 3 times here s by s square plus 1 square, correct? You can check. So now Laplace transform of sin 3t, a for 3 here, 3 by s square plus 9 square, 5 times a means 3 by s square plus a square, 3 square. Now we get 3 times s by s by s square plus 1, correct, plus 5 times 3 by s square plus 9. This equal to 3s by s square plus 1 plus 5 into 3 15 by s square plus 9. Let us solve the one more important problem, that is very important problem. So now find the Laplace transform of sin square of at. So this cannot be done directly using the basic formulae. So we have to put in terms of the basic formulae so that the problem can be solved. What does the sin square theta stands for? From multiples and submultiple angles chapter in trigonometry, in previous classes you might have studied, the 2 sin square theta is equal to 1 minus cos theta. Sin square theta is equal to 1 minus cos theta by 2. With the help of that formula, so this can be put in elementary as an elementary function, so that this Laplace transform of that can be evaluated now. So now first let us transform or let us convert in terms of the here multiple angles. Solution. We know that we know that 2 sin square theta equals to 1 minus cos 2 theta. Sin square theta 1 minus cos 2 theta by 2 or upon 2. In the place of theta we have 80. So therefore we can write sin square 80 is written in terms of sine of function cos of function 1 minus cos of 280 because theta is 80 here by 2. Now easily we can find out the Laplace transform of given function. Now the Laplace of sine square 80 can be written as Laplace transform of 1 minus cos 280 by 2 without disturbing its identity. It won't change. So now applying linearity property, we can write half times here Laplace transform of 1, am I correct, minus Laplace transform of cos 280. Now how many formulae do we recall? So we need to recall two formulae. What are those the formulae? One is Laplace transform of 1, that is 1 by s. Laplace transform of cos 80 has to be recalled here. So now Laplace transform of 1 whose value is 1 by s, correct. The Laplace transform of cos 80 is s by s square plus a square. So with the help of these two, this can be solved now. So this equal to half times Laplace transform 1 is 1 by s and minus here s only by s square plus here very interesting a for 2a we have, a for 2a, we get 2a whole square. Okay, so now let it be simplified. We get 1 by 2 times 1 by s minus, so what is the next one? S by s square plus 4a square. So now this can be simplified, 1 by 2 into 1 by s, 1 by 2s, correct, and minus s by 2 times s square plus 4a square.